सो गुड इवनिंग स्टूडेंट्स। सो कल मैंने आप लोगों को एक प्रॉब्लम सॉल्व करने दिया था। हैव यू डन दैट? किया क्या? यस या नो? नो आंसर, यानी नहीं अटेम्प्ट किया। ओके, डोंट वरी। सो व्हाट वाज दैट वन? दैट स्टेट psi for a harmonic oscillator is given as 1 by root 2 pi naught x plus 1 by root 2 pi 1 x. Some people have done this one, and 2 or 3 people have give the correct answer. So I am just going to complete it. Obviously, we can give it into kit form also. And you have to calculate the expectation value of x. And obviously, we have to calculate at t is equal to 0 and t is equal to some time t. So we have 4, so expectation value of x, we have 4 terms. The first term is half pi naught x pi naught. Second term is again half pi naught x, sorry, phi 1 x phi 1. The third term is again half. You can go for pi naught x phi 1, and the fourth term is 1 by 2 pi 1 x pi naught. So in last class we have discussed all these things, that this is nothing but the expectation value of x, and yes, harmonic oscillator is given, and that is given as Vx is equal to half m omega square x square. So this is just a generalized harmonic oscillator, and well-known thing is there. So this value is equal to what? 0. This value is again 0 because expectation value of x in a ground state of harmonic oscillator is 0. Expectation value of x in a first accelerated state is also 0. But these two terms are not 0. We have to just check what is the value of these two terms, and you will check that this value and this value will be always same, because everything is a real function. So when we have real function, we can easily write this particular thing. So anyway, so let's try to go for calculating phi naught x phi 1. So what is my phi naught? Phi naught is m omega upon pi h cat to the power 1 by 4 e to the power minus m omega x square upon 2h cat. X is the, I have to just use this space actually, because it will take lengthy space, more space it has to take. So we have to go for phi naught x phi 1, and that is basically, obviously we have to go for minus infinity to plus infinity. First phi naught, that is m omega upon pi h cat to the power 1 by 4, and the ground state is nothing but Gaussian, m omega x square upon 2h cat. X will operate on phi 1, it will give you x, and phi 1 is also there. So what is your phi 1? This phi 1 is m omega pi h cat is always there, that is 1 by 4. 1 by root 2 is there, and there is one more term, that is h1 xi and h1 alpha x. So you have this value is equal to root under m omega h cat, this is alpha, x, and Gaussian e to the power m omega x square upon 2h cat dx. So you have to just make this integration little bit in a compact form. So this will go with this one. So we have m omega upon pi h cat, that is 1 by 2. This and this will go with each other. this and this will be there. One, this factor and this factor is going to come outside. So m omega upon 2h cut will come outside. And inside this integration, we have minus infinity to plus infinity x square e to the power m omega x square upon h cut, because this will just a h cut. And we have dx here. Yes. Now the whole challenge is just we have to go for this integration. So what will be this integration? क्या होगा ये integration? So I can use this space. So let us put this value is some alpha naught. Okay. बाद में उसे adjust कर लेंगे. And what will be this integration? You can easily use gamma function, है ना? 2 into 1 by 2 x to the power n is there. So you have.
Sir.
Yes.
सर आपने जो psi 1 लिखा है उसमें एक 2 भी इनटू होगा ना?
Okay, yes. Okay, yes. So that will be 2 is also there. So 2 is also there. Okay. So 2 को भी हम बाहर ले लेंगे, है ना? So 1 2 is also there. 2 xi. Yes. 2 h1 is equal to 2x. Yes, 2 xi. Yes. Okay. So that value is equal to. So you can write something like that. 2, that is this 2 into, we have 1 upon m omega h cut to the power 3 by 2 and gamma 3 by 2. Isn't it? And you can multiply with 2 into 1 by 2 is also there. Because gamma integral is between 0 to infinity. So first, this is even integral. So you will just give 2. And for that particular gamma integral, we are putting the half value. Are you people able to understand this thing? ये समझ में आ रहा है ना? ये क्यों किया है?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now, what will be the final value? So this 2 and this 2 is also cancel out. What will be this final value? What is gamma root 3 by 2? So we have finally we have m omega upon pi h cut to the power 1 by 2. We have m omega upon 2h cut root under, and this final value is equal to h cut upon m omega to the power 3 by 2. We have just keep the reciprocal of this one, and 2 is also there, 1 2 is also there. And what is gamma 3 by 2? Half root pi. So this 2 is cancelled. And if you are going to calculate this all thing, then I think you will get h cut upon 2m omega. आ रहा है क्या? Just check it.
Yes, sir. Yes, sir.
आ रहा है ना? क्योंकि ये 3 by 2 है. And so कहीं कुछ गड़बड़ तो नहीं हो रहा है? Just a minute. This is half, this is root 2 plus, yes, that is 3 by 2. So h cut upon 2m omega. This 2 is cancelled. This pi is cancelled. So you have m omega upon h cut to the power 1. Yes, root 3 by 2. This will be 1 and this will be 3 by 2. So you have this particular value. ठीक है ना? So look at, you have to be very to keep patience when you are solving this integral. Now, so this value will be remain same. You can check it. So what will be expectation value of x? What is your expectation value of x? बताइए. Your expectation value of x will be this number and this number. So both will be same. So you have basically half into h cut upon 2m omega plus half into h cut upon 2m omega, and that value is equal to h cut upon 2m omega. So this is your value of expectation value of x. Now what will happen when after time t you are going to do? कौन सा टर्म चेंज हो जाएगा? What is going to happen? So at psi t, what is going to happen? 1 by root 2 pi naught x e to the power I, and what is E1? H cut minus I h cut omega by 2 h cut into t. Yes. And second term is 1 by 2 pi 1 e to the power minus I, and energy associated to phi 1 is 3 by 2 h cut omega t upon h cut. So again we have to calculate the expectation value of x. So first term is we will get half pi naught x pi naught. What will be second term? The reciprocal of this will be, so you will take a star, then this will be plus, this will be plus. So we can do all this thing in our mind. What will be second term? Pi 1 x pi 1. Now we have cross term, and cross term is very interesting. That is 1 by 2. And if we are taking the pi naught x phi 1, then phi naught will be bra. So this will be plus sign. So what we will get here? This will be plus sign, and this will have minus sign. So what we will get? Minus I omega t, isn't it? सही लिखा है या गलत लिखा हूं?
Yes, sir.
And last term 1 by 2 pi 1 x pi naught. What will be this term? So this will be plus and this will be minus. So what you will get?
E to the
power I
omega.
omega t. It's a beautiful thing. Now we have already calculated this one is 0. We have already calculated this one is 0. We have already calculated this number is nothing but h cut upon 2m omega root under. So you can take half h cut upon 2m omega root under, and you have e to the power I omega t plus e to the power minus I omega t, and this half will be go for this. So you this function will be what? Cos function. ऐसा ही होगा ना?
Yes,
Yes
sir.
or no?
Yes, sir.
Yes. So that value is some cos function, and look at, you will have feeling of classical mechanics. This is just a some x naught. This is just a dimension of what? This is just a dimension of length, isn't it? So what is the expectation value of x? It's something x naught cos omega t. At t is equal to 0, you have x naught. And now you can see this is just like as a classical thing. Are you getting my point? What is the solution of harmonic oscillator for classical picture? X is equal to a cos omega t and sin omega t, depends on initial condition, isn't it?
Yes, sir.
And yeah, now you can see this superposition on an average, my position is just behaving like a classical particle. And this is nothing but the average value of states, average value of x on the state psi. This is beautiful thing. You can analyze this thing. Now, can you calculate the what is expectation value of momentum here? बताओ. You can easily calculate the expectation value of momentum. What is this value? M dx upon dt. And now you can see this value is equal to m x naught omega minus sign will be there, sine omega t. And the expectation value of momentum at t is equal to 0 is 0 because this term is going to 0. But it is not always 0. Is that everything is okay from my side?
Yes, sir.
समझ में आ रहा है? And this is your behavior of average value of momentum. So whenever you are talking about the average value, you are actually on an average talking about the particle who's on an average. Classically, you are just talking about what has happened to this particular particle. So you have quantum mechanics, you have classical mechanics, but you cannot separate directly, okay, just live here, live here. There is a beautiful connection between quantum mechanics and classical mechanics. And this connection can become with a beautiful mathematical formulation of quantum mechanics. In general, if someone will ask you, what will be, how your position is varying with the time, so you will always say something like a cos omega t or sin omega t depends on initial condition if this is my potential. In quantum mechanics also, if I am talking about the expectation value of x, that is average thing. That is behaving exactly like something like classical mechanics. Isn't it? Something like this. And you should appreciate this beautiful problem. यहाँ तक clear है ना? चलो, let's come to next problem. So what we have let's say potential is x. This is very simple. You have wave function psi x is proportional to x e to the power minus m omega x square upon h cut. What will be associated energy? What will be associated energy?
3/2 h cut omega. 3/2 h cut omega.
सोच करके बताओ, सोच कर बताओ. Very interesting.
सर ओमेगा की जगह पे 2 ओमेगा हो जाएगा.
वेरी गुड. सबसे पहले आप गॉसियन पार्ट देखोगे. आपका जो जनरल थ्योरी कहता है, अगर आपका पोटेंशियल हाफ एम ओमेगा एक्स स्क्वायर है, तो गॉसियन पार्ट में क्या रहेगा? e to the power m omega x square upon 2h cut. So you have to write in this form. So when you are writing it in this form, then this 2 will compensate with omega. So what is your omega effective? So your omega effective is 2 omega. Now what is your value of n? And then you will see the algebraic part. When you will see the algebraic part, this x can be written as a Hermite polynomial of first n is equal to 1. X can be written something like this. So n is equal to 1. So answer will be n plus half, and n is equal to 1 half into h cut into 2 omega. So what will be answer? 3 h cut omega will be answer. So you have to be always prepare for, please always keep in mind, on the parameters and the counter number. The parameter is obviously omega. And what is your quantum number is all decided by this algebraic function. Algebraic into Gaussian is all about your harmonic oscillator. So first you have to see the Gaussian and try to figure it out. What will be your angular frequency? And then you can, once you can find angular frequency, then you go to the algebraic part and try to write in a basis of H1 or H2 or H3 in a basis of Hermite polynomial. You know what is the form of Hermite polynomial. And then use the postulates. Now, this is a little bit easier. I have explained each and everything. Now I am going to the next question, and this is mind-blowing. So can you please tell me what will be the associated eigenvalue? What will be associated eigenvalue?
Sir, E naught and 2 E naught.
So first you have to calculate value of omega. What is value of omega? Is omega.
Omega.
So that is in Gaussian form. Now you have to talk about the n. What is value of n?
It is 2.
Is 2? Only 2? Look at.
Equal to 0 also.
Yes, is equal to 0. What is, look at, what is your H2? H2 बताओ तो क्या है? बताया था क्लास में क्या है? 4x square. Let's all thing is 1. 4x square minus 2. So x square can be written as H2 plus 2 by 4. This is your x square. So your x square is H2 plus 2 into H naught by 4. So this x square in form of Hermite polynomial, this is H naught plus, leave it this number. Let's say this number is H2 plus C1 H1. And then you have Gaussian function. So your Gaussian function is m omega x square upon 2h cut. So yes, you have calculated your omega correctly.
Sir,
your
it
omega.
is
हाँ, बताओ.
H1 H naught आएगा ना?
H naught. Yes. Now H2 से associated क्या energy होगी? बताइए. N is equal to 2 plus half h cut omega. So your energy can be, that is what? 5h cut omega. है ना? 5 by 2 h cut omega. And another can be 0 plus half h cut omega. So that will be what? Half h cut omega. So what can be possible answer? Your measurement can be either h cut omega by 2 or 5 by 2 h cut omega. Yes?
Yes, sir.
So always keep in mind on Hermite polynomial, not just x square or x or something else. You are very lucky here that this x can be easily written as h1, but x square is written as a linear combination of h naught as well as h2. Yes? Clear, na?
Yes, sir.
Okay. So let's go for next problem. So today we will finish it. So I think I will go up to 9:20. Okay. And tomorrow I will take your class. Okay. At least one class I will take. In spite of we have Republic Day. So in the evening, I don't think there is any problem. Okay. Okay.
Yes, sir.
Okay, good. Look at this problem. This is mind blowing, awesome. And we have omega, angular frequency omega, mass m. And what we are going to do, we have put the charge q here on this particular mass. And we have put this whole system into electric field, E naught. Now, this system is oscillating in an electric field, E naught. So my question is that, what will be energy eigenvalue for this particular system? So, first we have to go for the classical Hamiltonian, then only you can go up to the quantum mechanical Hamiltonian. So what will be your kinetic energy? The kinetic energy is something like this. There are two types of potential energy. One is half m omega square x square plus you have also potential energy due to electric field, and that potential energy is minus q E naught x, isn't it? सही लिखा हो ना? अभी तो आपका EMT चल रहा है, सो आपने तो ये सब कर लिया होगा. Del V upon del x is equal to E, है ना? With the negative sign. यही है ना? So you can easily find this one. And we have initial condition at the origin of this source of electric field is from equilibrium point. So there is not any constant. So this is my Hamiltonian. And if this is my Hamiltonian, this is the square part and this is the linear part. So what we can do? I can keep my kinetic energy something like that. But what I will do, I will just make a perfect square to my potential energy. Look at how we can do. I can take m omega square x square minus q E naught by m omega square. 2 is also there into x. So you have a square minus 2ab. So you can add q square upon m omega square 4 and you can subtract q square m omega square m square omega to the power 4 as well as E naught square. है ना? लिख सकते हैं इसके ऐसे क्या? लिख सकते हैं या नहीं?
Yes, sir.
Yes. So your Hamiltonian can be written as px square upon 2m plus half m omega square, and this is x minus q E naught upon m omega square whole square, and you have one constant term. And what is that constant term? Is minus q square E naught square upon 2m omega square. So this is your potential energy. Now, is that this is also a harmonic oscillator?
सर 2 नहीं है वहाँ पे.
2 आएगा, ये वाला 2 आ जाएगा. ठीक है?
ओके.
Clear है ना? Now, if you are going to plot this potential, अभी इसको रहने दो. This is just a constant number, just a constant value. If you are going to plot this potential, what is going to happen? Potential क्या हो रहा है? Centered at
Q E naught by m omega square.
तो ये कुछ ऐसा हो रहा है ना? Yes या no?
Yes, sir.
Is it just shifting towards right without changing omega? Omega is same. You can just put y here and You can have all equation in term of y also, और some z some xi put कर दो, पूरा equation change हो जाएगा. So your potential, if you are not taking this part, then it is just shifting without changing the parameter. What is going to change? That going to change is equilibrium point. क्या चेंज हो रहा है सिस्टम का? इक्विलिब्रियम पॉइंट. पहले जो हमारा सिस्टम था, वो हमारा सिस्टम क्या था? दैट इज px स्क्वायर अपॉन 2m प्लस हाफ m ओमेगा स्क्वायर x स्क्वायर. So our equilibrium point is something like this. If I have something like this, I am just translating my particle from 0 to here. Is that energy eigenvalue is going to change if you are moving the potential towards right or left without changing the parameter? Is that energy eigenvalue is going to change?
No, sir.
No, we have seen in the particle in box. So what will be energy eigenvalue up to this point? N plus half h cut omega. Omega is same. This is just equilibrium point is going to change. Now, if I am going to take this one is an integral part of this potential, then this potential is going to change something like this. होगा ना? This is just shifting the fundamental level, है ना? Just shifting the reference with the some constant value. So what is this constant value? Q square E naught square by 2m omega square with the negative sign. So we are shifting like that. So this whole potential will look like this. The whole potential is something look like this. So if potential is changing upward or lower, is that energy eigenvalue is going to change? Vertically change होने से energy eigenvalue change होता है? Give me answer.
चेंज होगा.
चेंज होगा. आपने देखा finite potential, infinite potential.
यस.
Yes, vertical अगर आप चेंज कर रहे हो, reference frame ही चेंज कर रहे हो, then obviously that will tend. This is constant part. So the answer is minus q square E naught square upon 2m omega square. This is your answer. Fundamentally correct. So what is your ground state wave function? कोई बता सकते हो क्या होगा ground state wave function? बताओ जरा. What will be psi naught x? Just tell me. अगर ये हमारा पोटेंशियल है, what will be psi naught x? भाई वेव फंक्शन तो ऐसा ही होगा ना? Something like this, isn't it?
Yes.
So चलो इसको रहने दो, इसको हम छोड़ देते हैं. If this is your potential, what will be your ground state energy? इसको रहने दो. This will be little bit maybe complicated. What will be ground state eigenfunction? Normalized one. Is that normalization constant is going to change? बताओ.
नो सर.
No. M omega upon pi h cut to the power 1 by 4. So what is going to change? E to the power m omega 2h cut. यहाँ क्या आ जाएगा? X minus
q e naught upon m.
very good. Q E naught upon m omega square का whole square. है ना? This will be your answer. Clear है ये? Leave it this one. I am just talking about this one. And what is the expectation value of x? बताओ. What is the expectation value of x in this case?
Just 0.
0. What is expectation value of x in this case?
Q E naught by
Q naught by
Exactly,
omega.
equilibrium point. Yes. Q E naught upon m omega square. This will be your expectation value of x. I am not talking about this one. I'm just talking about this one. If your potential is something like this, okay? So you can see how the concept we have generated in a particle in box in the formulation of quantum mechanics with the help of oscillates, all things can be come into this particular chapter. Let's go for the final one.
सर
Yes.
सर ये पोटेंशियल लेफ्ट में क्यों शिफ्ट है ये तो समझ आ गया सर ये डाउनवर्ड शिफ्ट नहीं समझ
इसके कारण इसका भी तो रोल रहेगा। ठीक है, ये पार्ट भी तो है।
तो डाउनवर्ड
अरे डाउनवर्ड नेगेटिव है भाई।
ओके ओके ओके
व्हाट इज दिस नेगेटिव साइन? अगर पॉजिटिव रहता तो अपवर्ड शिफ्ट हो जाता। ठीक है,
यस
ओके।
तो इस माइनस टर्म के कारण वेव फंक्शन में कोई चेंज आएगा?
माइनस टर्म के कारण वेव फंक्शन कोई खास चेंज तो आना नहीं चाहिए, बट लिव इट दैट पार्ट। वो आपके लिए मेरे हिसाब से कोई खास अंतर नहीं पड़ेगा उसमें। ठीक है, बट यस वर्टिकली थोड़ा चेंज होने के कारण थोड़ा बहुत हो सकता है, बट डोंट गो फॉर दिस। ठीक है, नाउ लुक एट हियर, दिस क्वेश्चन इज अ TIFR level question. Just go for this. Initially the spring constant is K and it is suddenly changed to 4K. K से किस में चेंज हो जा रहा है? 4K में। So आप क्वेश्चन लिखो, a particle is in ground state of a particle is in ground state of harmonic oscillator with spring constant K. Suddenly spring constant change to 4K. What will be probability? Particle is in still ground state. Still ground state means ground state of new harmonic oscillator, isn't it? That means ground state of new oscillator. Okay. So पहला जो पोटेंशियल था, what is your first potential? Vx is equal to half m omega square x square. And what is value of K? M omega square. है ना? ठीक है? This is your m omega square. So initially your potential is something like this, and your state is in ground state. So your phi naught is m omega pi h cut to the power 1 by 4, and you can use e to the power m omega x square upon 2h cut. Now what will be your new K? 4K हो जा रहा है, isn't it? So what will be your new omega? बताइए। K is equal to m omega square, and this is 4K is equal to m omega 1 square. So what is your new omega? 2 times omega?
2
Huh?
omega.
2 omega. So omega 1 is equal to 2 omega. So your new ground state is pi naught, that is m 2 omega pi h cat to the power 1 by 4 e to the power m 2 omega x square upon 2h cat. This is your new. So you have to calculate probability, and what will be energy associated with this particular energy, a particular wave function? H cat omega, है ना?
Yes,
So
sir.
what will be probability such that your particle will be still in a ground state or in a ground state of new oscillator? So how you will calculate it? The particle ground state of the new potential will be, क्या हो जाएगा ये? Pi naught n, pi naught old जो दिया हुआ है, mod square and obviously pi naught. यही होगा ना?
Yes, sir.
Yes. And now you have to just go for calculating this particular integration. अब यहां पर आपका इंटीग्रेशन दोनों केस में कहां से कहां पर है? माइनस इंफिनिटी टू प्लस इंफिनिटी. So you will go for minus infinity to plus infinity. What is this value? Is 2m omega upon pi h cat to the power 1 by 4 e to the power minus m. So this value is omega x square upon h cat, and here is m omega upon pi h cat to the power 1 by 4 e to the power m omega x square upon 2h cat into dx. क्लियर है ये? और नीचे वाला पार्ट तो नॉर्मलाइज है, दोनों ही केस में इज नॉर्मलाइज. सो दिस इज 1. यू कैन इजिली कैलकुलेट दिस थिंग. कैलकुलेट कर लोगे? बेसिकली क्या मिलेगा आपको? कैलकुलेट करना होगा 3m ओमेगा x, यही होगा ना, 3/2, and all thing can become outside. So I am just making it little bit cleaner. So just take all this thing outside. 2m omega upon pi h cat 1 by 4 m omega pi h cat 1 by 4, and you have to go for integration minus infinity to plus infinity e to the power, so 3/2 minus 3/2 m omega x square dx. And you have to take the mod square. Okay, अब तो हो जाएगा ना?
Yes, sir.
You have to take mod square also. Okay, mod square. And if you will calculate it, then you will get approximately 0.94. So 94% chance that your particle will be still in ground state. ठीक है? So this type of problem can come into your exam. So I haven't used any operator here, number operator, raising operator, lowering operator. We will use it into the advanced part of harmonic oscillator, where you will see the complex questions can be very easily solved. Okay, so this is from my side of harmonic oscillator. Tomorrow we will go for 2-dimension, 3-dimensional box, and I will just try to take 2 classes such that I will finish this very simple topic in a stretch.
हेलो
Yes.
हाँ जी चाचा
बोलिए.
सर
हाँ बोलिए।
सर यहाँ पे वही वाला मतलब लगाया है वो लॉजिक के, ये जो मतलब सडन चेंज हुआ है
यस
इसीलिए।
यस यस, ऑब्वियसली ऑब्वियसली। सडन चेंज पर स्टेट आपका क्या रहेगा? सेम रहेगा,
ओके सर।
है ना? वेरी गुड। तो आप लॉजिक वही लगा रहे हैं, सडन चेंज वाली। सडन चेंज स्टेट ऑफ अ सिस्टम is not going to change. ओके, स्टेट ऑफ अ सिस्टम, तो स्टेट हमारा यही है ना? इसी कारण ये बाद में लिखा हुआ है, ठीक है? और किस में देख रहे हैं ग्राउंड स्टेट? न्यू वाले में का ग्राउंड स्टेट में है। न्यू पोटेंशियल जो आपका जनरेट हो रहा है उसके ग्राउंड स्टेट में है। ओके,
यस सर।
अगर ओल्ड का देखते तो ये इधर आ जाता, ये भी इधर आ जाता, उससे भी आपका सेम ही आंसर आता, डोंट वरी, है ना? ठीक है, बिकॉज बोथ आर नॉर्मलाइज, सो नीचे वाला पार्ट चेंज हो जाएगा, बट दैट इज ऑल्सो नॉर्मलाइज, सो यू कैन।
सर
हाँ बताओ।
सर आई हैव डाउट दैट मुझे किसी ने बोल दिया कि हार्मोनिक ऑसिलेटर का एनर्जी 6 स्क्वायर ओमेगा, एंड उसने मुझे ओमेगा के बारे में कुछ भी नहीं बताया, तो आई विल थिंक दैट दिस इज माय एवरेज एनर्जी 6 स्क्वायर ओमेगा।
नहीं, अब हार्मोनिक, अब देखो क्वेश्चन समझने की कोशिश करो। अगर किसी ने बोला कि आपको हार्मोनिक ऑसिलेटर है और उसकी एनर्जी 6 ओमेगा है, और अगर उसने ओमेगा के बाद, पहली बात तो ये आइगन स्टेट है या नहीं है?
यस सर।
ठीक है, सो यस, वेरी रूड फॉर्म में आप बोल सकते हो चलो ये एवरेज वैल्यू ऑफ एनर्जी होगी।
ओमेगा के बारे में नहीं बताया तो।
ओमेगा के बारे में नहीं बात करने का मतलब ही नहीं है ना, क्योंकि तो पैरामीटर है, समझ रहे हो?
यस सर।
समझने की कोशिश करो। किसी भी प्रॉब्लम को आप पैरामीटर तो देना ही पड़ेगा। कितना बड़ा बॉक्स, कितना फास्ट हार्मोनिक ऑसिलेटर हो रहा है, ये तो बताना पड़ेगा आपको ना,
यस सर।
तभी तो आप एनालाइज करोगे,
यस।
है ना? ये क्वेश्चन तब मजेदार होता, देखो तुम्हारे क्वेश्चन को मैं मजेदार बनाता हूं। ये क्वेश्चन होता कि हार्मोनिक ऑसिलेटर मेरा वही है, हार्मोनिक ऑसिलेटर, फेमस हार्मोनिक ऑसिलेटर, हाफ एम ओमेगा एक्स स्क्वायर, और मेरी एनर्जी जो है, कोई बोलता है कि मुझे 6 ओमेगा एनर्जी मिल रही है, कोई ये तुमसे कह रहा है।
यस सर।
इसका मतलब ये है कि 6 ओमेगा एनर्जी किसी आइगन स्टेट की तो नहीं हो सकती है,
नहीं सर।
यानी कि पार्टिकल आपका किसी एक आइगन स्टेट के बारे में तो नहीं बात कर रहा है, क्योंकि अगर
Yes,
उसके
sir.
बारे में बात करता देन एनर्जी मस्ट बी हाफ ओमेगा,
Yes, sir.
3/2 ओमेगा,
Yes.
5/2 ओमेगा, 7/2 ओमेगा।
Yes, sir.
लेकिन फिर भी वो बोल रहा है कि माई एनर्जी इज 6 ओमेगा, दैट मीन्स ही इज टॉकिंग अबाउट एवरेज वैल्यू ऑफ एनर्जी, जो कि कोई भी ऐसा स्टेट होगा जिस स्टेट का एवरेज वैल्यू ऑफ एनर्जी क्या हो रहा है, 6 ओमेगा हो रहा होगा। हो सकता है उसमें? नहीं,
Yes, sir.
दो का सुपर पोजिशन करके 6 ओमेगा जैसी चीजें आ सकती है।
Yes, sir. बेसिस स्टेट होगा ये।
तो वो, तो उस समय वो क्या होगा? तो आपसे कोई क्वेश्चन पूछेगा कि ये बताओ, इज दैट एनर्जी, इज दैट योर स्टेट इज आइगन स्टेट? नो,
No, sir. आइगन स्टेट नहीं है।
नहीं है, तो आइगन स्टेट का सुपर पोजिशन होगा।
Yes, sir.
तो अब बोलेगा कि इसमें से कौन सा सुपर पोजिशन है, तो तुम बोलोगे अच्छा भी तुरंत बताता हूं, तो आप मुझे 2 3 4 ऑप्शन दो सुपर पोजिशन के। तो वो वाले सुपर, मान लो सपोज समवन विल आस्क यू सुपर पोजिशन ए, सुपर पोजिशन बी, सुपर पोजिशन सी, यू विल जस्ट फाइंड द एवरेज वैल्यू ऑफ सुपर पोजिशन ए।
Yes,
अगर
sir.
6 ओमेगा आ रहा है तो वो भी हो सकता है, बी
Yes,
का आ
sir.
भी सकता है, नहीं भी ऐसा आ रहा है तो वो भी हो सकता है। आर यू गेटिंग माई पॉइंट?
Yes, sir.
है ना?
नॉर्मलाइज करके निकल सकते हैं।
जैसे भी निकल जाए
Yes,
आप,
yes, sir. Yes.
बिल्कुल आप जैसे भी निकल जाए, बट एवरेज वैल्यू तो लाने के कई तरीके हो सकते हैं ना,
Yes, sir.
सिर्फ एक ही सुपर पोजिशन से थोड़ी मिल सकता है वो एवरेज वैल्यू,
नहीं सर।
नहीं मिल सकता है। ठीक है, सो जस्ट ट्राई टू थिंक। देखो इन जनरल लोग आपको ये कर देते हैं, जब आप शायद कभी क्वांटम मैकेनिक्स पढ़े होगे तो क्लासिकल को बिल्कुल अलग कर देते हैं, बट थोड़ा साथ साथ लेकर के चलने की कोशिश करो, तो आपको बहुत मजा आएगा। जैसे आज आपने देखा एक्स का कितना बढ़िया फॉर्म आ रहा है, नहीं?
यस सर।
कॉस ओमेगा टी के जैसा आ रहा है फॉर्म। दिस इज जस्ट क्लासिकल थिंग, है कि नहीं? और वो जो 5 पोस्टुलेट्स है, दिस इज माइंड ब्लोइंग, माइंड ब्लोइंग। एनीवे,
यस सर।
चलो आज के लिए इतना ही रहने देते हैं। सो आई थिंक इट्स अ डिनर टाइम। टेक केयर, थैंक यू,
थैंक यू सर। गुड नाइट सर।
Thank you,
गुड
sir.
नाइट।